With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, here is our question. In the network shown in given figure, find the potential difference across B, D. Okay, so this is the network given here. We have to find the potential difference across B and D. That means if point B have potential VB and point D has potential VD, then we have to find VB minus VD. Okay, so now let us try to find out the current flowing in this circuit. That will help us to find the potential drop across these resistors. Okay, so now first of all we have to find the equivalent of this circuit. Now we can see here that if the current I is flowing in this circuit, then here current will flow is equal to I1, then here it will be I minus I1. Okay, and this same current will flow through this resistance of 10 ohm. So we can say that 5 ohm and this 10 ohm are in series combination. So in series combination, the equivalent is given by R1 plus R2. Okay, so the value of R1 here is 5 ohm plus R2 is 10 ohm. So their series equivalent will be equals to 15 ohm. Okay, now these two are also in series because the same current is flowing through these two resistors. Okay, and the value of resistance is also 10 ohm and 5 ohm. Okay, so their series equivalent will also be equals to 15 ohm. Now we can replace these two resistors by a single resistance of 15 ohm, and similarly these two are replaced by a single resistor of 15 ohm. Now this 15 ohm and this 15 ohm are in parallel combination because they have same potential difference across these two. Okay, so in parallel equivalent is given by 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. Okay, so the value of R1 here is 15 and R2 is also 15. Okay, so from this we have the parallel equivalent here is equals to 15 by 2, that means it is equals to 7.5 ohm. So here this is the simpler circuit for the above given complex circuit. Okay, now we can find the value of current in this circuit by using Ohm's law. Okay, Ohm's law says that current is equals to potential difference divided by resistance. So it is 3 divided by 7.5. Okay, now let us try to find this. So it will be 3 divided by 7.5. This will be equals to 2 upon 5 ampere. Okay, so the current flowing in this circuit is equals to 2 divided by 5 ampere. Now look here, that is the value of I here is 2 by 5 ampere. Okay, here we have two paths for this current. Okay, one through this resistor of 15 ohm and one through this resistor of 15 ohm. And these two resistors are equal, that means the current will equally divide in these two paths. Okay, so the value of I1 will be equals to I by 2, that will be equals to 1 by 5 ampere. Okay, so the current passing through this circuit is equals to 1 by 5 ampere, and also through this circuit it is 1 upon 5 ampere. Okay, so current through this 10 ohm will be 1 upon 5, and through this 5 ohm it is also 1 upon 5 ampere. Okay, now applying nodal analysis. In nodal analysis we can take any one point at 0 volt voltage. Okay, so it is at 0 volt. Now this point will be at potential 3 volt because here we gained a potential of 3 volt. Okay, now the current of 1 upon 5 ampere is flowing through this resistor. So potential drop across this 10 ohm resistor will be equals to current into resistance. So current here is 1 upon 5 into resistance is 10. Okay, so it will be equals to 2 volt. That means the potential drop across this resistance is 2 volt. Okay, and the current is flowing in this direction, and we know in the direction of current the potential decreases. So the potential of this point B will be equals to 2 volt. Okay. Now similarly, the potential difference across this 5 ohm resistance will be equals to 1 upon 5 into 5, and that is equals to 1 volt. Okay, so the potential of this point VD will be equals to 1 volt, because the direction of current here is in this direction, and in the direction of current the potential decreases. Okay, the potential difference across this is equals to 1 volt, so the potential of this point will be equals to 1 volt. Now we have to find the value of VB minus VD. Okay, the value of VB here is 2 volt that we have just calculated, and VD is 1 volt. Okay, so VB2 minus VD1, so it will be equals to 1 volt. Okay, so the answer for this question is 1 volt, that is the potential difference across point B and D will be equals to 1 volt. So that's our solution for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.